Okay, so on this extension that we're going to be doing here, so on the front side, you're just going to find all the lengths of the missing sides and the missing angles by using law of sines. So again, if I were doing this, I'd have to find the last angle that I'm missing right here, the angle C right there. So again, I can do 180 minus 75 minus 26 to find my last angle. And sometimes this can be a little bit confusing. This right here is just saying that this side length AB is 12. And so what I can do is I can set up my proportion, cross multiply, and solve to find what side lengths A and B are. Once I do that, and maybe I should give you guys a little bit of an example. So I'm going to find that last angle there. So 180 minus 75. Sorry, I don't have another calculator, so I got to do this on Desmos. 180, 75, 26 minus 26. So that gives me 79. So I know that this angle, is going to be 79 degrees. And so then I can set up my proportion, remembering that it's always the sine of the angle, and then the side that's across from it. And then I can choose either one. If I want to find out what side A is, again, I got to use the angle across from A, which is the 75-degree angle. So I can go like this, and then I can cross multiply and divide. So I have 12 times the sine of 75 is equal to A times the sine of 79. And then I can divide both sides by the sine of 79. That's a big calculation that I can do, which would then give me the length of side A. Once I do that, I can do the same proportion, except I can find out what side length B is. Once I do that, then there's a pattern with triangles. So I want to find the biggest angle in all the examples, and then which side is always across from the biggest angle, and then the smallest angle, which side is always across from it. When you get over here to the back, this is kind of a little bit tricky, but this is using regular trig, so sine, cosine, and tangent. And what I want you to do is, and just so you know, these problems go with these triangles, and then down here, these problems go with these triangles. And so what I want you to do here is I want us to draw and find all of our sides and angles by using regular trig. So the way that this works is, if I know that the cosine of angle A is 0.6, again, that's 6/10 as a fraction. And so what I want you to be able to do here is, so I want to use 6/10 as my fraction, which I could also reduce down to 3/5. And remembering the definition of cosine. So cosine means adjacent over hypotenuse. And so I know that if in my picture here, so cosine of A means that I start at A. So I'm going to start, I'm going to put a little angle mark in here. So I'm starting at this angle, and from that angle, the ratio of the adjacent over the hypotenuse is 3/5, or if you wanted to use 6/10, that's the same thing. So what I could do is I could say that if I start at A, since the cosine of A is 3/5, the adjacent side to A, which is here, is 3, and then my hypotenuse is 5. Again, from there, I could then find the other side. I could use Pythagorean Theorem to figure out what the other side is, and I can also find the other angles. So I could actually go ahead and do, whenever I'm finding an angle, I do second sine or inverse, second sine, cosine, or tangent. So I could do second cosine. So when I go over here, I can go, so there's my second cosine right there. And then I go 3/5, and that gives me, I'm in radians right now. So if I click over here and go to degrees, there we go, that's better. 53.1. This angle is 53.1, and I know that I could then find out what angle B is. Let's see. Well, so again, I know all the sides are going to add up. So 36.9 would be the other one. 36.9, yep. And then I could find the other side here, because I know the Pythagorean theorem is a squared plus b squared equals c squared. Just making sure that my hypotenuse, which is this one right here, is always the one that's by itself on the other side. So that gives me x squared plus 9 equals 25. Subtract the 9, which gives me 16, and take the square root, so I would know that this missing side right there is 4. It's a 3, 4, 5 triangle. And I can do that for the rest of them. So I can do them for question numbers 4 and 5, and then I can go down and do them with these ones. What you'll end up having is some of these will not work. And then what I want you to do at the bottom is I want you to figure out, why did certain triangles not work when I tried to figure out the other side length, or tried to do my second sine, cosine, or tangent. There'll be some, and there's a definitive reason on why they did not work. So that's kind of the idea behind this worksheet. So have fun. Let me know if you have any questions.